So we were discussing propositional logic. What are WFF? Yesterday we have discussed WFF are well-formed formula, and sentences are known as WFF. So instead of sentences, we will be using WFF. So what are the examples of WFF? If P is a sentence, P is a WFF. True is WFF. P and Q is also WFF. P or Q implies R. Since P or Q is also forming a proposition, and let consider it to be Z, then P or Q implies R. This will combinedly form a proposition, so it is also an WFF. Then P and Q or R implies S. Not of P or Q. Not of P or Q implies R and S. These all are propositions, and these are the examples of WFF, that is well-formed formula. So what is the meaning of what is semantics? First is to be interpret what is P in particular world. We will be discussing what is world. After having meaningful sentence, we evaluate it whether it is true or a false sentence. Sentences can be compound, that is after combining two proposition sentence, it form a compound sentences 2 or 3. It should be interpreted in same world. Then each statement or each sentences of a compound sentence is interpreted. Then we assign a truth values to each interpretation. Then compute the truth value of the combined proposition. For example, if we have a propositional logic representation, as we can how we represent a propositional logic is, for example, he campaigns hard. It can be represented as a statement P, and Q, he will be elected, that is Q. So if he campaigns hard, then he will be elected. So we first calculate the values whether it is true or false for he campaigns hard. Then we evaluate for that he will be elected. So once this known that P is true, then Q will maybe true or false. Then according to that, this compound sentence will be evaluated to true or false. And what is world? That is, if let's assume there is a sentence, it is hot. With respect to summer, this can be true, and with respect to rainy, it can be false. So the world is summer or rainy. Out of this, the sentence can be true or not true, valid or not a valid sentence. This depends on another world. For example, it is humid is also true in rainy, and it is false on summer. So it's also depend on the world. So we try to evaluate the meaning of a sentence according to the world. What are the properties of a statement? If a statement is true in a particular world, then it is satisfied by that world. But if it is not necessary valid statement is known as constituent or satisfiable. A statement is invalid if and only if it is not true for at least one interpretation. A statement is known as contradiction or unsatisfiable if and only if it is false under all its interpretation. If a statement is true irrespective of the world, it is valid or tautology. For example, P or not Q is always true. It is independent of the world we are working. For example, if P is true, then not P can be false, and or of P or not Q will give me true. And if we take P as false, then false or not P as true, it will give T true for the combined sentence. So irrespective of the world, this statement P or not Q is always going to be true. We can have truth truth value derivation of P. If P we consider false false true true and Q as false true false true, then for respective combination we are having P and Q and P or Q and P implies Q. And so P implies Q as it we can see that if P is false and Q is true, then P implies Q can be true, and if P is true and Q is false, then it is always false. And what are the laws of propositional logic? There's too many laws of propositional logic, but here I am discussing only 2 laws. And before going to the law, as we may have some sentences, this sentence we have to prove whether it is a valid or contradiction or invalid kind of thing. So first we can have false true false true false kind of thing for P, and for Q that is false false true true for P, and Q for Q also we can have false true false. And similarly we can fill all the entries of not P, then not of P or Q, then P and Q, this side P and Q, not of P and Q, this is not of P and Q, and after this we can put a implies symbol to that and calculate this and this, and we then corresponding true and false and true and false value for this. So after having this value we can check whether it is all true. If it's all true, then it is a valid. If it's all false, it is a contradiction. So now let's move to the De Morgan's law. So what is De Morgan's law? De Morgan's law is if we are having P and Q and negation before it, the negation can be moved in and we can have not of P or not of Q. And if we are having not of P or Q, negation can be moved in and is equal to not of P and not of Q. So this is equal, both sides are correct. So this is a De Morgan's theorem, and according to above statement, this can also be proved. And next we have some reasoning kind of properties. For example, if some P kind of statement is given and Q is also given, and P implies Q is given and P is given, then what will be the solution? We have to find. Let's suppose here solution is not given and we have to find what is the solution. For example, here we have taken an example. For example, he campaigns hard, he will be elected. So as a sentence it is given, he campaigns hard and then he will be elected. If he campaigns hard, then he will be elected. This is a R, and again P is given, that is he campaigned hard. So what will be the solution of it? As this both sentences are true and this P is also true, then it is implies Q, that is he will be elected. So this property is known as Modus Ponens. Okay. For example, we can have proof for this. If P implies Q, P implies Q can also be written as not P or Q, and P is also given. So P and not of P or Q will lead to P and not of P or Q. P and not of P is false, and false or Q. So Q can be true or false. So or value depend on means false, or q depends on what is the q. So we can have false or q is equal to q. We are having so many properties in propositional logic, but I have discussed only 2 properties, and that's all for today. Next class we will be discussing first order logic. Thank you.